Hey everybody, it's Miss Hill, and I am here to just review the Pythagorean theorem video that you just watched through Math Antics and give you an opportunity to check the notes that you recorded as well as just fill in some things that I think are really important about working with the Pythagorean theorem. So first off, I wrote down the definition they shared, which is that for a right triangle, that's super important that it's a right triangle, with legs A and B, and a hypotenuse, a crazy math word, hypotenuse, C, we have the formula a squared plus b squared equals c squared. Underneath that, I recorded an example diagram for you. So if you didn't get one of these down during the notes or during the video, go ahead and jot down this example triangle. This is an example of a right triangle. The way I know that it's a right triangle is there is a little baby square that is noted in one of the bottom corners. And that corner creates a perfectly 90-degree angle, which we call a right angle. So that's the first thing that I notice, and I know it's a right triangle, therefore I know I can use the Pythagorean theorem. You'll see that blue arrow that I have, and that is pointing toward the hypotenuse. So one of the very most important skills you can have in working with the Pythagorean theorem is identifying the hypotenuse. We need to know that one specifically because it's all by itself on the right-hand side of the equation. A and B can be used interchangeably. You don't need to be super specific about A and B, but C you have to identify that one correctly. So that's the first step I always take, is I always look for that right angle little square, and I draw a diagonal line, an arrow pointing toward that hypotenuse, because I want to identify that first. So that blue arrow, that's what that is. That's pointing towards C, the hypotenuse. And then I just labeled A and B as the other two legs. You might hear us call them sides. The official name for the A and B would be a leg. And then I have over on the side, you can see I jotted down the formula again, a squared plus b squared equals c squared, and reminded myself of what a squared means. A squared means I'm going to multiply a times a. B squared means I'm going to multiply b times b. And c squared means I'm going to multiply c times c. And so I just wanted to put that little notification for myself so I wouldn't forget what that really means. Next, this was the first example that they went through on the video, and he gave you the example of what we call a 3-4-5 triangle. It's one of the most common triangles used when you're talking about Pythagorean theorem. It's called the 3-4-5 triangle, and it's named for all of its sides, right? So side A is 3, B is 4, and C is 5. If you're ever trying to figure out, well, which side would be 5, it's always going to be the hypotenuse. That's always the longest side, so that would always be C. And then they walked you through plugging that into the formula a squared plus b squared equals c squared. 3 goes in for A, 4 goes in for B, 5 goes in for C. Now, just like solving any kind of equation, what I first want to deal with are those exponents. I don't want to add the 3 and the 4 and get 7 and then square that. That would be an entirely different answer. So I'm thinking of PEMDAS, and I want to deal with those exponents first. So I go ahead and I square everything. 3 squared means 3 times 3, that's 9. 4 squared means 4 times 4, which is 16. And 5 squared is 5 times 5, which is 25. And then when I add the 9 and 16, you notice both sides end up equaling 25. So I put the little pink check, meaning yes, this works out. This is a right triangle because I can use the Pythagorean theorem to solve. The next example that he walked you through was how to find a missing side. And this was the example of when your hypotenuse, or side C, is the side that's missing. So again, labeling carefully, that pink arrow is pointing toward the hypotenuse from the right angle. A squared plus b squared equals c squared is always my formula, and I'm always going to write it down before I plug in any numbers. 2 goes in for A, 3 went in for B, C is what I'm looking for. I went ahead and then next line, I squared the 2 and I squared the 3. I got 4 and 9. Add them up for 13. Now you're stuck. 13 equals C squared. Well, the only way to find out what C equals is to find the square root. It's kind of like the opposite of squaring something. So instead of multiplying it by itself, I'm actually thinking, well, what times itself would give me that? Well, C squared, the square root of that is C, because C times C will give me C squared. And then I need to find the square root of 13. In the video, he expressed that you could leave your answer as a square root. You can also go ahead and plug that into your calculator and find out what that answer would be, in this case 3.6. Next, he went on and shared with you a few more examples. So this example at the top would be what would happen if I'm looking for either side A or B. So if I know what C is and I'm looking for one of the other sides, same formula. I have a little extra step, and that extra step is happening right here. When you end up with 16 plus B squared is equal to 36, I need to subtract the 16 in order to isolate the B squared, in order to get B squared by itself so that I can solve. So that was an extra little step in there. And then I went ahead and did the square root of B squared, which is B, and the square root of 20, which I rounded off to 4.47. For our purposes, a lot of the quizzes that you're going to take, they are going to go ahead and find the square root of the number. So get in the habit of practicing that with your calculator. The next example was just kind of more of a real life situation, like how would I find this diagonal line that cuts through a square? Well, the great thing I know about a square is all of those angles are 90 degrees, so I know this is going to be a right triangle. A and B are both 1. So you can see I went ahead and plugged those into Pythagorean Theorem and solved for C, which came out to be 1.4. When I square 1, 1 squared is 1 times 1, that's still 1. So for both A squared and B squared, I ended up getting 1, added those together for 2. That's where I needed to find the square root of 2. The final example that he walked you through was the question of, well, I'm going to give you all the sides, but you need to tell me, is this a right triangle or not? So in this case, this was not a right triangle. Doesn't mean it's not a triangle. It can absolutely still be a three-sided shape, which is a triangle, but it's not a right triangle, meaning none of the angles inside this triangle are going to be 90 degrees. The way I know that is I used Pythagorean Theorem. A squared plus B squared equals C squared. So if I take A and B as 3, and I use the longest side, so the biggest number I've got, and plug that in for C, the hypotenuse, when I solve both sides of that equation, you notice that I get 18 on the left and 16 on the right. Well, that's not the same. That is not equal to each other. So when that happens, when the two sides of that equation are not equal, my answer is no, this is not a right triangle. Still a triangle, just not a right triangle. I hope that review helped. Make sure you've copied down all of these notes. We'll provide you with the PDF as well, so you have these in your spiral. Next up is a practice worksheet and then a quiz for the end of this lesson. Have a great day.